Good morning. Let's look at trigonometry with obtuse angles. After all the excitement of doing bearings recently, this is quite a small concept in a way, but important. So grab your calculator for a second and do something with me, and we'll try and make sense of what's happening over here. What are they talking about here? I think we probably remember that obtuse angles are angles between 90 and 180. So you might want to make a note of that. And let's talk though first about acute angles. Acute angles which are 0 to 90. Grab your calculator. Let's pick an angle between 0 and 90. How about 50? Do this with me. Find the sine of 50. Do you notice it's 0.766, right? But it's a positive number there, isn't it? Positive number. Okay. Let's try cos of 50. Cos of 50. 0.6427, yep. Another positive number, and if you do tan of 50, yeah, there we are, 1.19, so we see that that is also positive. And if you try any angle between 0 and 90, sine will always be positive, cos will always be positive, tan will always be positive. Okay, what about other angles? Well, if we look at obtuse angles between the angles that are from 90 to 180, let's pick one of those. So what about 110? So let's choose 110. So let's find the sine of 110, sine 110. We should have got 0.939, so we see that it is positive. Okay, another positive number. Let's try cos of 110, cos of 110. That's a negative number, all right? And if you do tan of 110, you get another negative number, don't you? Minus 2.747. Okay, so in summary, all we're taking away from this sheet is sine's always positive if it's less than 90, and when we're between 90 and 180, it's negative for cos and tan, but for sine is positive. Okay, let's move on. This is a diagram that really just summarizes that work. So ASTC, some people remember it as all stations to central, but it's really just summarizing what we did. In the first quadrant, that is from 0 to 90, it's just really the same on the previous slide. They're all positive, aren't they? And then if we go from 90 to 180, the only one that was positive is sine. We actually don't have to worry about these bottom quadrants. That's not such an important slide. Okay. Let's do these ones now. So this is just calculator work to start with. And this is heading somewhere. To start with, it just seems like we're just doing some pushing buttons, but it does end up going somewhere. So let's grab our calculators, and notice with this first one, it's actually sine 164.25 degrees. It's not 25 minutes or anything, it's 0.25, so it's decimal. So we just type it in, sine 164.25, close the brackets. Okay, and we'll see what the answer is. We get 0.27, 144. Okay, and we'll round that to 2 decimal places, it says, so that's equal to 0.27 to 2 decimal places. Okay, let's do the next one, this time with degrees and minutes, isn't it? So it's tan 124 degrees, 30 minutes, and so we should have that on a calculator when we're entering it, and we've used that keys for those that's forgotten. There we are, entering that, and we get minus 1.45, 55, ... and we're going to 2 decimal places, so that's going to be minus 1.46, isn't it, to 2 decimal places. Okay, now if you recall this one, the next ones, it's saying, given cos theta equals this, find the value of theta. We are finding an angle, so you would remember if you're finding an angle, you press shift, don't you? On Abacus calculators, its second function. So I'm going to press, if I'm finding an angle, it's going to be second function or shift cos minus 0.5178, close the bracket, so that's what I've typed in. And when we do that, we get 121.18, so that's 121.18. And what we're really typing in there is, so we've got, so it's 121 theta is equal to 121.18, and we're going to the nearest degree, so that's going to be 121 degrees to the nearest degree. Okay, let's do this last one here. And this is an interesting one. This one's going to be a little bit different. We'll get an unusual result, I think. So we're finding an angle. So it's going to be shift tan, and then it's minus 1.32. Close the brackets, and we get, theta equals negative, and we go to the nearest minute. So it's negative 52.8533. Now, when we get a negative, right, we need to make a note here. So make sure you put this in your booklet. Right, we're going to say note. If you get a negative angle, add 180 degrees. So that's key, right? Negative angles, you add 180. So we're going to take that value that's on there, just leave it on the calculator that was before, plus 180 equals, all right, so plus 180, I get theta equals 127.1466, ... And it says to the nearest minute, so if you remember how to do that, you're using this button here, aren't you? And you're going, there we are, and it flips it to 127 degrees, 8 minutes, and 48 seconds. Now, because this is over 30, because there's 60 seconds in a minute, if we go into the nearest minute, that's going to be 127.9, isn't it? So 127 degrees, 9 minutes. Okay, nice. Okay, now, so what's our takeaway from that page? The key thing is the thing in red. If we get a negative angle, when we're doing shift, we add 180. Okay. And you're really going to only get those with these tan negative ones. But you don't have to worry about that. Negative angle, add 180. Okay, let's move on. Okay, more calculator work. All right, we haven't got to the big result from this lesson yet. We're going to get there shortly, but this is just calculator work. So let's enter this in the calculator. So find the angle. Oh, notice it says the obtuse angle. So I'm expecting my angles to be between 90 and 180, aren't I? And so let's do this on the calculator. So finding an angle, shift cos, shift cos, and then I've got to do put my fraction in. Well, actually I'll put minus, then the fraction. Then I've got square root of 2 on the top, over 5, close the bracket, equals, okay, so I get 106.4299, theta equals 106.4299, and we go to the nearest degree, theta equals 106 degrees. Okay, let's do the next one. So again, finding an angle, shift cos, and this time it's going to be minus fraction, square root of 3 over 2, close the brackets, equals, and I get theta equals 150. Theta equals 150. Now, what's interesting here is they said I was going to get obtuse angles, and sure enough I do. Well, this next one will be a little interesting. Right, off I go. So usual way. In this case, it's going to be sine this time. Still finding an angle, so it's shift, sine, and I've got my fraction, so it's going to be 1 over square root of 2. Equals, whoa, 45. So, you know, if we're not paying attention, we'd think, oh, that's right. There we are. I've done everything the same. I've done that right. But it did say an obtuse angle, didn't it? So this one is actually not right. We're just going to come back to that one, right? So let's put a little asterisk that we're going to come back in a moment, and we'll see once we do a little bit more learning what we've actually got to do to this one. And the learning really is going to come shortly. So we're going to come back, leave that one there. Let's do these ones, more of these, and off we go. Calculator again, same kind of thing. Notice obtuse angle, so I'm expecting these to be angles between 90 and 180, so off we go. So shift, tan, fraction, minus, or I could have put it at the front. Won't make a difference, I don't think. Minus 11, square root of 11 over 2. Over I go, close the bracket. Nice, and so when I do that, I get minus 58. Ooh, minus 58. What did we learn earlier about if we get negative angles? We've already learned something with that. Right? We add 180, don't we? So if we do that, we get 121.09 dot dot dot, and it says that wants it as a to the nearest minute. So in this case, there we go. So we've got 121, 5, 27, so it's just under half, so it's 121 because we got 60, so the halfway mark is 30, 60 seconds in a minute. So it's going to be 121 degrees, 5 minutes. Cool. Okay, let's go with the next one. Theta equals, so, and I'm probably going to suggest as you're watching these videos, probably a good thing to do is to actually pause them, do the question yourself, and then restart it to see if you've actually got it right. I think that would be a good way throughout lots of these videos rather than just watching a teacher do it. Anyway, shift tan, we've got minus fraction square root of 3 over 3, close the brackets, tan to the minus 1, there we are, make sure that's right, yes, equals, we get minus 30. Ooh, minus 30, what do we remember? Minus 30 degrees. We're going to add 180, and we get 150 degrees. Okay, no minutes, of course, because it's just a whole degree. Let's do the next one. Theta equals, it's going to be, we're going to go with this one, finding an angle. So it's shift, sine, fraction, square root of 10. Oh, forgot the fraction. Let's get rid of that. There we go. Square root of 10 over 8. Close the brackets. Equals 23.28. Ooh, not obtuse. I'm going to have to fix this one up too. I'll tell you how shortly. We're getting there. Let's do that to the nearest minute. So nearest minute it says, so that's 23:17, isn't it? 23:17. Right. Okay, now, just leave that on your calculator for a second. Actually, no, let's go to, let's do something. Now we want to get to the important part of the lesson, when we're actually going to learn where this has all been heading. Grab your calculator for a second, clear that off, and do this with me. Let's choose, so what I want us to do is, let's do the sine of, do this with me, do the sine of 10 have a look what we get. I get 0.1736, right? Now let's do the sine of 170. Same thing. Let's pick another number. What about 20? Sine of 20. Have a look. 0.34. Sine of 160. 0.34. Same thing. One more. See if you're noticing the pattern. Sine 5. 0.087. Sine 175. Same thing. Have you noticed what is the pattern between every time I'm choosing a pair? And I can keep choosing pairs that will always be the same. Did you notice? Like the last one, 175 and 5. Each of those pairs added up to 180. So you're going to get the same result for if you put 5 in as you do if you put 175. If you put 10 in, that'll be the same as 170. If you put 20 in, that'll be the same as the sine of 160. Now, why is that important? Well, it's important when you're finding angles, because when the calculator spits out a result, and we'll just go to the next slide. We're going to come back, because we've got to come back to that one, because it's not right. 2 slides to go back to. This is the big result page, right? When we, let's do this one now. The sine, so if I want to do this one, sine of 0.5, okay? What do we normally do? So forget about it, was just the last couple of slides, but how do we normally do this? We go shift, second function, sine, because I'm finding an angle, aren't I? I'm finding an angle, so second function, 0.5, oops, 0.5, try again. Okay, so I get 30, x this time instead of theta, doesn't matter. X equals 30, but do you agree it could be 30, or have a look at this. What's the pair that would go with this? If, I was doing the 10 and the 170, the 5 and the 175, what would be the pair that goes with this? Well, you actually do 180 minus it, don't you? Right, so basically 150. So it could be, x could be 180 minus the 30, which is 150, right? Show you on your calculator, right? So the calculator will always spit out the acute angle, and if you're after the obtuse, you just subtract it from 130, because look at sine 150. Sine 150. It's 0.5, isn't it? So there's 2 angles that could be giving us a 0.5. It could be the 30, which the calculator will always give you, or it could be 150. So let's read what this says. This is the key bit for this lesson, really. The sine ratio and obtuse angle. So it's only about sine. The other ones we don't have to worry about, apart from if we get negative angles, we've got to add that 180. When finding a missing angle using shift sine, or second function if you've got the abacus calculator, it will always give you the acute angle. It will always give you this one. We can find, there is also an obtuse angle. We can find this by subtracting from our calculator. Now you might be thinking, well, why haven't I come across this before? Well, generally we've been working with right angle triangles, so you never get any angles over 180. But now we're going to be starting to work with triangles that aren't. Shortly, we'll be starting to work with triangles that aren't. So you might have an angle, right, that is bigger than 180. So we don't have to, it's not too stressful. All we've learned so far this lesson is, if you get a negative angle, you add 180. And when you're doing sine, if they're after for an obtuse, you won't get any warning. You've just got to read the questions carefully. You've actually got to subtract it from 180. So let's go back to this one here. So I did this the normal way, right? Back to slide 30 we are on here, I believe. And I got 45, doing it the normal way. But if it was an obtuse angle, do you agree theta is actually equal to 180 minus 45? Which is, if you do that in a calculator, 135 degrees. So that's actually not correct, right? You might get that when you do it. You might do it as a little bit of side working, but the angle is 135. And when we did this one on the next page, right, we notice it's an obtuse angle. So if I get an angle that's less, right, that's all I've got to notice. If I get an angle that's less, what have I got to do? My theta is actually 180 minus 23 degrees 17. Now, on our calculator, let's get a bit of practice at this if we want to do this, right? So if we're doing 180, we've got to do it here. Here we are. So why don't we do 180 minus 23/17? 180 minus 23 degrees 17 equals, whoa, 180 minus 23 degrees 17 minutes equals, that's better, 156. We'll write it to the nearest minute because that's what they wanted. 156 degrees 43. And we had to re-enter that, but normally right back here, when I got this answer, first of all, I would have just subtracted that from 180. So I would have gone 180 minus answer, because that would have been stored in there. So it's not like you've got to usually re-enter it. When you notice, if you're finding an obtuse angle, that's what you do. Okay, let's keep moving. So we've done both those slides. Let's move on to some final angle answers then. Here we are. Yep, we've got this one, only one more to go, question 13. So let's have a look. Given that cos theta equals -8 and the angle is between 90 and 80, what does that mean? Between 90 and 80? That just means it's obtuse. So all those things we've learnt, we've just got to bear in mind. Find the value of theta, find tan theta, and find sine theta. Okay, right. Well, let's do the first one. So this is find theta. So off I go. It's just going to be shift, entering that. Let's see what we get. So we're finding an angle. So we don't worry too much about this. This was really just saying it's obtuse. Away we go. Shift, cos. And I guess I should be talking about how we'd normally set this out. Cos to the -1. So we'd have a question which is cos theta equals -0.8. Then we're going cos to the -1. Theta equals cos to the -1 negative 0.8. And that's going to be equal to 143. We're going to the nearest degree, so that's just going to be 143 degrees. Then for B, we are doing, we're finding tan theta. Okay, so we've now got the angle, and we'll actually keep all those decimal places, right? We should keep those places in the calculator, so I'm keeping them there on my screen. In fact, I'll actually write them down. So, because theta is actually to all the decimal places is 143.130. Okay, and then it says, find tan theta. Now, within this course generally, even though we've rounded this to 143, we should put all the places in for other answers, right? Because it hasn't said use the rounded one, so we would generally use the full value. So tan theta is going to be equal to, and let's be clear here, are we finding an angle in this one? We're not. This one was finding an angle. This is finding a ratio, so we won't be pressing shift for this one, will we? We won't be pressing shift for this one. So tan theta, so that's really, you've got to get really clear. Shift is only when you're finding an angle. The rest of the time, you're just pressing tan. So in this case, I'm pressing, and I've got to keep all those places. 130.1024. It's in my calculator, so the nice way around that is I can just go tan, can't I? So I can go tan, and then rather than typing that in again, I'll just go tan answer. Right, that'll bring back that 143. Press equals, and I get minus 0.75. So tan theta equals minus 0.75. Right, it's not an angle, is it? It's a ratio when you're pressing that. And if I want sine theta, well, here I've really got to enter the number again, because so it's going to be shift sine, and then I've got 143 point, oh sorry, not shift sine, breaking my rule. I'm not finding an angle, I'm just finding the ratio. It's sine, so it's sine 143.131024, close that, equals, okay, and we're going to 1 decimal place. Ooh, 1 decimal place, let's have a look at this. Sine theta equals 0.599, there it is. And so theta is, sine theta is going to be equal to, if we're going to 1 decimal place, look to the right, 9 or more, that goes up, isn't it? It becomes a 10, so that becomes a 0.6. Do we agree? 0.6. So, in summary, what have we learnt this lesson? We've learnt that a little bit about obtuse angles, and that is when you're doing these, as we go ahead through the rest of this chapter, dealing with non-right angle triangles, like things like that, all kinds of things that aren't right angles. If ever we come across a negative angle when we're finding an angle, we just add 180. That was anytime we get a negative angle coming out of the calculator. And with sine ratios, we've got to be careful. If we're finding an angle, if they ask for an obtuse, then you've got to subtract that acute angle from the 180. Okay, hopefully that helps. More next time.